is I'm taking that one acidic buffer, particularly weak acid is HEA is a one weak acid is there. This HEA weak acid, if it is reacting with its a strong base and it forms, this is an salt is a Ba salt is a formed. Ba is a salt of HEA weak acid and the strong base is a BOH, and this mixture is acting as a acidic buffer. For this acidic buffer we need to find out its pH of the pH calculation, right? So how we can able to find, first there is an I am taking that there is an these are present in the beaker, and HA is going to be attaining the ionic equilibrium, because this is a H plus ion concentration and this is an A minus ion concentration, and here it is in a Ba. So this Ba will be dissociated into B plus plus, and here it is an A minus ion. A minus ion is a common ion effect is there. This HA is a weak electrolyte. Now here ionic equilibrium is formed between the undissociated HA molecule and dissociated H plus and A minus. So for this you can write down the its equilibrium constant K, or this equilibrium constant I can write this particularly, this is for the acid now, so that I can write this is directly Ka is the equilibrium constant, and here it is now H plus ion, product of molar concentration of products to product of molar concentration of reactant. So here A minus ion concentration divided by this is in a particularly HA concentration. Okay, so here for calculation of pH, for finding of pH, definitely H plus ion concentration should be required. So that I am making this H plus ion concentration as a subject of the formula, and H plus ion concentration is equals to, you can make this H plus ion concentration as a subject of the formula, and you can take this all this side, then what you will get, this is in a Ka into concentration of HEA divided by, here it is in a concentration of A minus. So here concentration of A minus is always equals to the it's a concentration of salt, because it's a common ion effect, because of the common ion effect. So it's a whatever, this is a weak electrolyte, this is a 100% ionization. This weak electrolyte generally 5% 10% ionization takes place, and more percentage of A minus ions are present, are coming from only for the strong salt. So that salt is a Ba. That's the reason A minus ion concentration is always equals to the, it's a Ba concentration. Anyway, this particularly whatever the A, due to the common ion effect, this A minus ion concentration is equals to the, it's a salt concentration we can say. So now instead of A minus ion concentration I can write this Ba concentration. This Ba is nothing but simply a salt, right? So here H plus ion concentration is equals to, and I can write this is a Ka into, so this is a particularly HEA concentration divided by, here it is it's a salt concentration Ba. Okay, take minus log on both sides. When we are taking the minus log on both sides, I will get this is in a minus log of here it is in a H plus ion concentration, and this will be the E log m into n. Here minus log of Ka, this is a minus log of log HA concentration divided by, here it is a concentration of Ba, right? So this is a minus log of H plus ion concentration is nothing but we can write down this is a pH, and this is a pKa, and this is actually you can reverse this one, minus log of this is acid concentration divided by salt concentration is there. HA is acid and Ba is a salt, so that you can take making the plus, I can write this is in a log of this is Ba concentration divided by, and here it is in a HA concentration. As all we know, this Ba is a salt here, This is a salt, and this one is a weak acid. So that we can write finally pH is equals to, this is pKa plus this is a log concentration of salt divided by the concentration of acid, we can write. So this is the final equation to find out its pH of the acidic buffer. These equations are called as this equations was derived by the Henderson scientist. These equations are called as the Henderson equation. This is for the acidic buffer. pH of a basic buffer. pH of a basic buffer, I am taking that basic buffer is a weak base. Whenever it is reacting with a strong acid, it forms a salt. That salt, the general form I was taken as a Ba. BOH plus Ba is acting as a basic buffer. This BOH is a weak base now, so that it will be undergo the extent of ionization and it forms ionic equilibrium, B plus and OH minus, and here Ba is a B plus and A minus. Again here also common ion effect is there. This common ion effect will suppresses the dissociation of BOH, and for calculation of pH definitely here H plus ion concentration or OH minus ion concentration should be required. But here OH minus ion concentration, first you write equilibrium constant for this ionic equilibrium. Kb is equals to product of molar concentration of product divided by its a reactant BOH. OH minus ion you can make the subject of the formula here, and Kb into your concentration of BOH divided by your concentration of B plus ion. So due to the common ion effect here, H plus B plus ion concentration should be equals to the Ba concentration here, and you can substitute in the above equation. You will get that OH minus ion concentration equals to, this is Kb into BOH concentration divided by Ba. By taking the minus log on both sides, minus log of OH minus log of Kb and minus log of BOH by Ba concentration. Minus log of POH is nothing but POH. This is PKB, and reverse this one, you will get plus log salt concentration divided by its a base concentration. You got only a here POH. So from that we can calculate the pH. pH is equals to 14 minus POH. So 14 minus POH value was written in a bracket. You can simplify even further this one also. So these equations are given by the Henderson scientist. That's the reason these equations are called as Henderson equations. Calculation of pH for the acidic buffer and basic buffer was done by the Henderson scientist. That's the reason we can call it as it's a Henderson equations.